So now let's consider the following scenario. You have developed an application feature, you have tested it, and now you're ready to deploy it, right? To deploy it, your application should be packaged into its own Docker container. So this means that we're gonna build a Docker image from our JavaScript Node.js backend application and prepare it to be deployed on some environment. To review this diagram that we saw at the beginning of the tutorial, so we have developed a JavaScript application, we have used the MongoDB Docker container to use it, and now it's time to commit it to the Git, right? So in this case, we're gonna simulate this on the local environment, but still, I'm gonna show you how these steps actually work. So after commit, you have a continuous integration that runs. So the question is, what does actually Jenkins do with this application? When it builds the application, so the JavaScript application using the npm build, etc., it packages it then in a Docker image and then pushes it into a Docker repository. So we're going to actually simulate what Jenkins does with their application and how it actually packages it into a Docker image on the local environment. So I'm going to do all of this on my laptop, but it's basically the same thing that Jenkins will do. And then on later step, we can actually push the built image into a Docker repository. In order to build a Docker image from an application, we basically have to copy the contents of that application into the Dockerfile. It could be an artifact that we built. In our case, we just have 3 files, so we're going to copy them directly in the image and we're going to configure it. And in order to do that, we're going to use a blueprint for building images, which is called a Dockerfile. So let's actually see what is a Dockerfile and how it actually looks like. So as I mentioned, Dockerfile is a blueprint for creating Docker images. A syntax of a Dockerfile is super simple. So the first line of every Dockerfile is from image. So whatever image you're building, you always want to base it on another image. In our case, we have a JavaScript application with Node.js backend, so we're gonna need Node inside of our container so that it can run our Node application, instead of basing it on a Linux Alpine or some other lower level image, because then we would have to install Node ourselves on it. So we are taking a ready Node image. And in order to see that, let's actually go to Docker Hub and search Node here. And here you see there is a ready Node image that we can base our own image from. So here we have a lot of different tags, so we can actually use one specific one, or we can just go with the latest if we don't specify any tag. So what that actually means, basing our own image on a Node image, is that we are gonna have Node installed inside of our image. So when we start a container and we actually get a terminal of the container, we can see that Node command is available because there's Node installed there. This is what from Node actually gives us. So the next one is we can configure environmental variables inside our Dockerfile. Now, as you know, we have already done this using the Docker run commands or the Docker compose. So this will be just an alternative to defining environmental variables in a Docker compose, for example. I would say it's better to define the environmental variables externally in a Docker compose file, because if something changes, you can actually override it. You can change the Docker compose file and override it instead of rebuilding the image. But this is an option. So this env command basically would translate to setting the environmental variables inside of the image environment. The next one is run. So all these capital case words that you see from env and run, they're basically part of a syntax of a Docker file. So using run, basically you can execute any kind of Linux commands. So you see, make directory is a Linux command that creates a home/home/app directory. Very important to note here. This directory is gonna live inside of a container. So when I start a container from this image, the /home/app directory will be created inside of the container and not on my laptop, not on the host. So all these commands that you have in Dockerfile will apply to the container environment. None of them will be affecting my host environment or my laptop environment. So with run, basically you can execute any Linux commands that you want. So that's probably one of the most used ones. And we also have a copy command. Now you would probably ask, I can execute a copy command, a Linux copy command using run. Yes, you could. But the difference here is that, as I said, all these commands in run, for example, they get executed inside of the container. The copy command that you see here, it actually executes on the host. And you see the first parameter is dot, and the second parameter is /home/app. So source and the target. So I can copy files that I have on my host inside of that container image. Because if I were to execute run cp source destination, that command would execute inside of the Docker container. But I have the files that I want to copy on my host. And the last one, so from and cmd or command, is always part of Dockerfile. What command does is basically executes an entry point Linux command. So this line with the command actually translates to node server.js. So remember here, we actually do node server.js. So we start a node server with the node.js. This is exactly what it does, but inside of the container. So once we copy our server.js and other files inside of a container, we can then execute node server.js. And we are able to do it because we are basing on the node image that already has node pre-installed. And we are going to see all this in action. So another question here, what is the difference between run and cmd? I could also say run node server.js. The difference again is that cmd is an entry point command. So you can have multiple run commands with different Linux commands, but cmd is just one. And that marks for Dockerfile that this is the command that you want to execute as an entry point. So that basically runs the server and that's it. So now let's actually create the Dockerfile. And just like the Docker Compose file, Dockerfile is part of the application code. So I'm going to create a new file here and I'm going to paste here the contents. And you can see here that Visual Studio Code, notice that it is a Docker file, so the icon here will change, as well as the syntax highlighting in the editor for the Docker file will also change. So again, we're basing off node image, and actually instead of just having the latest node, I'm gonna specify a node version. So I'm going to take version 20 Alpine. So all of these that you see here are different tags, so I can use any of these versions. So I'm going to say this one here, which I can add to my Docker file. Like this. So this is going to be a specific node image that I'm going to use as my base image. Let's actually stop here for a moment and take a little bit of a deep dive on this line. So since we saw that Dockerfile is a blueprint for any Docker image, that should actually mean that every Docker image that there is on Docker Hub should be built on its own Dockerfile, right? So let's actually look at one of the latest versions here and then click inside. And as you see, this specific image has its own Dockerfile. And here, as you see, we have the same from that we just saw. And this is what this node official image is based off, which is a base image Alpine, right? And then we have this environmental variable set and all these Linux commands using run and some other environmental variable. And you have this entry point, which is a script. So you can also execute the whole shell script instead of separate commands. And you have this final command, right? So you don't have to understand any of this. I just want to demonstrate that every image is based off another base image, right? So in order to actually visually comprehend how this layer stacking works with images, let's consider this simplified visualization. So our own image that we're building, app with the version 1.0, is going to be based on a node image with a specific version. That's why we're going to specify from node 20 Alpine. And the node 20 Alpine image, as we saw in the Dockerfile, is based on an Alpine image with the version 3.17. That's why it specifies from Alpine 3.17. So Alpine is a lightweight Linux image that we install Node on top of, and then we install our own application on top of that base image. And basically this is how all the images are built. So now let's go back and complete our Dockerfile. So we have the from specified, we have the environmental variables specified, and in just a second we're going to actually see these commands in action. So let's copy that and then save the file. And this is a very important point. The file must be saved with the file name Dockerfile. You can't just give it any name you want. It is always called Dockerfile, starting with a capital D, and that's it, with no extension at the end. So now that we have a Dockerfile ready, let's see how to actually use it. So how do we build an image out of it? In order to build an image from Dockerfile, we will run a Docker subcommand called build. So Docker build. And to that Docker build command, we have to provide two parameters. One is we want to give our image a name and a tag, just like all the other images have. So we are going to do it using -t. So we're going to call our image my app, and we're going to give it a tag of 1.0. The tag could be anything. You can even call it actually version 1. It wouldn't matter. So we're going to do 1.0. And the second required parameter actually is a location of a Docker file, because we want to tell Docker, here, build an image using this Docker file. And in this case, because we're in the same folder as the Docker file, we're just going to say current directory. And when we execute this, we're going to see that it's pulling the node image from the Docker Hub and then building the app image, which is going to take a few seconds. As you see in the build logs, Docker shows us the execution steps from Dockerfile that we defined. So we had 3 Dockerfile instructions, or 3 steps to build the image. And we see the execution, 1 from 3, or the second step from 3 steps, and the third step. And finally, we see the image ID of the image that we built. So now with the Docker images, I can actually see that my image is here. So I have the image name, which is this one here, and I have the name of the image and the tag of the image. So if we go back to this diagram that we saw in the review, so basically we've gone all these steps, or we have simulated some of the steps. We've built the JavaScript application using a Docker containers. And once the application is ready, let's say we made the commit, and we just simulated what Jenkins server also does. So what Jenkins does is actually it takes the Docker file that we create. So we have to commit the Docker file into the repository with the code. And Jenkins will then build a Docker image based on the Docker file. And what is an important point here is that usually you don't develop alone, you are in the team. So other people might want to have access to that up-to-date image of your application that you developed. It could be a tester maybe who wants to pull that image and test it locally, or you want that image to be deployed on a development server, right? And in order to do that, you have to actually share the image. So it is pushed into a Docker repository, and from there, either people can take it, for example, a tester maybe want to download the image from there and test it locally, or a development server can actually pull it from there. So let's actually just run a container. I'm just going to say docker run, the image name, obviously, and a tag like this. And in this case, I'm not going to specify any other options because we just want to see what's going on inside of the container. So I'm just going to run it. Okay, so the problem is that it can't find the server.js file, which is actually logical because we're not telling it to look in the correct directory. Now, there are two more optimizations to our Dockerfile that we need to do. First of all, we can set a default working directory, which is going to be this home/app folder, because this folder will contain the project files like the server.js. So here, if I add workdir instruction with home/app location, what this will do is basically set a default working directory inside the Docker container. So when Docker container starts, based on this image, all the following commands that we have in the Dockerfile following the workdir command will be executed in that home/app directory. So we won't need to use the full path home/app/server.js to actually execute or run that server.js file. Instead, we can just do node server.js, as you see here, and it will automatically be executed in whatever we set as the work directory. And we also need to add the npm install command to our Dockerfile here as well. So I'm going to add run npm install here. And the reason we want to add it here is that instead of taking the node modules that we have on our host inside the project, instead of taking those node modules and copying it into the image, we want to execute npm install and generate that node modules folder with all the dependencies inside while creating the Docker image to make sure that we always have the most up-to-date versions of those dependencies. Because it could be that we have executed npm install some time ago and we have those older node modules dependencies, and we don't want to take that with us and put that in the Docker image. So we adjust our Dockerfile to only copy the application files, including the package.json file, and not include the node modules folder when copying. Instead, it is going to be generated when executing npm install command in the Dockerfile, which will get executed while building the image. So we will make sure to always have the up-to-date versions of dependencies in the node modules folder. And if the package.json file changes and we make some adjustment there with the version or the dependency and we rebuild the image, we will have those changes inside the image as well. And that's it, because we already specified the working directory. npm install command will automatically be run in home/app folder that we specified above, which means we don't need to specify an absolute path anywhere in the Dockerfile following the workdir command. And this is another topic. Whenever you adjust a Dockerfile, you have to rebuild an image because the old image cannot be overwritten, so to say. So what I'm going to do now is I'm going to delete the one that I built. So I'm going to actually take the image. This is how you delete an image. But I can't delete it because, as it says, the image is being used by a container. So we can't delete that. So if I do docker ps -a, actually let's grep to my app like this. I have to first delete the container. So this is how you delete a container. It's docker rm. And once I've deleted the container, I can delete an image. So the image deletion is rmi, like this. So if I do images now, I see my image isn't there. Okay, so we have modified the Dockerfile. So let's rebuild it now. So docker build again. And let's see, the image is here. So let's start it again. So it's my app 1.0 and let's run it. And as you see, the problem is fixed, app listening on port 3000. So our app is running. So this one here, my app 1.0. First of all, we can see the logs here like this. We see that the app is listening on port 3000. We know everything is cool. To actually just get a little bit more insight, let's enter the container, or let's get the terminal, the command line terminal of the container, and look around there. So I'm going to say docker exec interactive terminal. I'm going to specify the container ID in bash like this. And since bin bash doesn't work, we can actually try shell. So this is something you will also encounter because some containers do not have bash installed. So we'll have to connect using bin sh. So one of them has to work always. So let's see in which directory we are. So we are in the root directory and we see our virtual file system there. And as you see, the cursor changed as well. So that means we're inside of a container. So now let's actually check some of the stuff. So first of all, we specified some environmental variables here in the Docker file. And this means that these environmental variables have to be set inside the Docker environment. So if we do env, we actually see the MongoDB username, this one here, and MongoDB password are set. And there are some other environmental variables automatically set. We don't care about them. So another thing we can check is this directory, because remember, because with this line, we actually created this /home/app directory. So let's see /home/app. And as you can see, the directory was created. And with the next line, we copied everything in the current folder. So if we actually go and see reveal in Finder. So this is where the Docker file resides. So basically we copied everything that is inside of this directory. So all of this into the container. Now, we don't actually need to have Dockerfile and this other stuff in here because the only thing we need are the JavaScript files, or if we build a JavaScript application artifact, just the artifact. So let's go ahead and improve that. So what I'm going to do is I'm going to create an app directory and I'm going to copy just the files that I'm going to need for starting an application inside of a container. We only need server.js, index.html, and package.json files, and the images folder. Because since we added npm install in our Docker file, it will automatically generate up-to-date node modules and package log.json file every time we build the image. So we shouldn't copy them into the image. This means now we only have the needed files in the app folder. Everything we don't need in the Docker image is outside in the root folder. So what we can do now is instead of copying the whole directory where the Docker file is, I just want to copy all the contents of app folder. So what I'm going to do is I'm going to say copy all the app contents. And again, because we modified a Docker file, we need to recreate the image. In order to leave the Docker container terminal, you can actually exit. So now we are on the host again. So if I do Docker images, again, I have to first delete the container and then image. But in order to delete the container, I have to first stop it. So now I can remove the container. And now I can actually remove the image that the container was based on. And let's check again. So let's execute that build command again. So now that we have the image built, let's actually run it. So I'm going to say my app 1.0. And of course I could have executed with a -d in a detached mode. It doesn't matter now. And if I do docker ps, I see my image container running. And now let's actually enter the container again. So it. And as we learned, it was in sh. And again, we're going to see the home app. And here we just have the contents of app directory. And as you see here, the node modules and package log.json was automatically generated when npm install directive in Dockerfile was executed, because we need this to run the application. So we see them here as well. So no unnecessary Dockerfile, etc. files, which is actually how it's supposed to be. Or as I said, because I just had a couple of files here, I copied all of them. But usually if you have this huge application, you would want to compress them and package them into an artifact and then copy that artifact into a Docker image container. Okay, but as I said, this was just for demonstration purposes, because I just wanted to show you how you can actually start it as a container and how it actually look inside. And in this case, we improved a couple of things, but usually we would start this container from a Docker Compose as well, together with all the other Docker images that the application uses.